You're being recorded. Okay.
So hi everyone, this is the second workflow workshop session and we are very happy to have Dr. Bruce here. So he'll be taking a session on statistics department cluster. So this was one of the topics which was pretty demanding while I sent the registration, and I don't think so I need to introduce Dr. Bruce, but still he's very well known in our department, and any cluster doubts we send it to him. So his research interest is developing scalable algorithms in the field of time series and longitudinal data. Some of his other interests are sports analytics, using statistical implementation there, then applications of statistics in biomedical settings, and and data science as well, right? So yeah, that's what I think of.
Thank you all for being here. Thank you all for those of you that are online. So I want to, so hopefully make sure everyone is set up okay. Do you have access to the document that I'm working out of right now in the folder? So Sunjit, did you send out the?
Yes, I have sent that.
Okay, so there should be a link to this directory. Let me find it for you. That should have these components in it. So I'm going to be catering.
Sorry, so about which address? I didn't receive it.
Yeah, so it has been emailed to the channel address which you have.
Maybe it will arrive.
It takes a few minutes because it is being sent to, I guess, around 300 participants.
Right. Then let me
300 or?
Yeah, the 300 emails.
let me set the tone here. So the audience for this workshop are complete newbies. All right. So I'm assuming that you know nothing about the cluster, right? So if that's, how many of you would say you're in that? Okay. The computer. All right. Okay. Very good. Okay. So that means that if you already know something about the cluster and how to use it, you might be a little bored. Okay. But nonetheless, I think we'll make do. So I'm going to start it from the ground up. That means that if you have an experience that deviates from what I'm sharing here, or if you want to add your own perspective, for those of you that have experience with the cluster, feel free to chime in at any point. And you're going to get the most out of this session if you are following along on your own machine, right? So basically doing the same things that I'm doing. And I've already asked for a little bit of bandwidth on the cluster because we have a handful of heavy users that are currently using it pretty regularly. So was there a question online, or was that just feedback on my end?
Just feedback, I guess.
Okay, good. Okay, all right, very good. So how many of you have requested an account already? Everyone? Okay, Gio, we got to get you to request an account. Okay, very good. So if you haven't already done so, you can request an account by emailing artsci. Okay, very good. artsci.help@tamu.edu, and then adding this information. So if you want to get instructions, since you're on the network that are a little bit more legible, you want to go to arsivan.stat.tamu.edu, and that'll take you to the website for the cluster. So if there's any point where you're working with the cluster and you're not sure what to do or where to go, this is going to be your one-stop shop. Okay. So it's got all the information about the cluster. It's got the acknowledgement. So any research that you do using the cluster's resources, we want to know about it, because if we can provide a list of those citations that were made possible through the cluster and the computing resources there, we want to present that to the college so that way we can get more funding to help support it. Okay? So it's really, really important that any research that you guys have going on, any papers that come out of it, in the acknowledgements of the paper, just include the language here. Portions of this research were conducted with the advanced computing resources provided by the stat department computing cluster. Okay. So that makes it official. And then also you can fill out this citation form that provides information about the publication. It doesn't have to be fully accepted. It can be a preprint, whatever the case is. Just make sure that we have some way to get to it. So that way we can make a stronger case to the college 5 years from now when we have to invest some resources in updating it. Okay. Very good. Okay. And in terms of access to you, so if you, and for anyone else who needs to apply for an account, if you go to the access page, just send an email to artsci.help@tamu.edu with all this information. and they will get you an account approved usually within a day or two. It depends on how quickly Matthew can turn it around. He's our counterpart in IT that helps make sure this thing is running smoothly. Okay. Very good. All right. So for those of you that have access, we're gonna just plug along, and I'm gonna introduce you to some of the basic workflows and some of the easier ways that you can interact with the cluster. Okay. So how many? I see a lot of Macs. I don't see so many Windows machines. Okay. I think most everyone in the room is Mac. So when SCP is out the door for you, but FileZilla is a way that you can get access to some easier file transfers. So if you go to the web, search for FileZilla, and click on this, click on the download, where's it? Download the client. And I'm going to copy this link and paste it in the Google Doc. So that way we have it. Hey. Am I still sharing my screen?
No.
So we need to client.
Hmm?
We need to client.
Did it stop? Come on. Please.
Just click on the,
So it's up there, I guess. You have hide the panel.
yeah.
So you can just click on that participant window.
This one?
Yeah.
You just enlarge it.
Oh, okay. Yeah, I'm not sharing. Okay, all right. Let me. Hold on. There's some in the chat. Can Sonja, are you monitoring the chat?
Yeah, so I just share in like, yeah.
Got it. Perfect. Okay, all right.
It's
Okay,
not.
all right. So now if we go here, I'm going to take this download link, copy it, and I'm just going to paste it in here under. Okay, all right. So you want to go there, download this client, and it will provide you with a graphical user interface that makes it so much easier to take files from your local, transfer to the cluster, and vice versa. So the interface that I'm going to be using is for Windows machines using WinSCP, but the inputs are going to be the same whether you're using FileZilla or whether you're using WinSCP. All right, very good. So let's continue. One other note here is that if you are planning to use this at home, and you want to access the cluster when you're not on Temu's network, you have to VPN in first. Okay, so how many of you are familiar with a VPN in order to get onto Temu's network? Okay, good. So if you're not sure how to do that, you go to Temu VPN. Let me find. Very good. I'll add this link to the website as well. Connecting. Very good. Okay. And I'll post that in here at the top. Instructions for accessing the cluster from outside the Temu network. All right, does this link work? Let me double check it. Yeah, it does. Perfect. Okay, so that's not important now. If you're here in the classroom, you're on the network, right? So you're good. But for those of you online, if you're trying to connect and follow along at home, you're going to have to use the VPN. And if you haven't done so already, you'll have to install Cisco's VPN client in order to connect to the A&M network first. The way that you know if you're connected or not is if you go to if you go to the RCVN website here and you try to connect to it, if you're not on the network, it's going to say it's not there. Okay, you can only access this website when you're connected to the network. So just make sure that you're connected to the VPN, and then you can try to access this website. If you've done so successfully, then you'll be able to access the website and the information you're in. Okay. All right, so now the reason I start here is because file transfers are usually the most complicated thing and the thing that you need to be able to do. So you need to be able to take your scripts that you're developing on your local, move them to the cluster so you can run them. And then when you get the results from your simulations, you need to be able to take the summaries and then pull them back down. So this file transfer process is really important to make it easy for you. So, so I'm going to make sure that everyone's set up on either WinSCP or on FileZilla before we continue. So this is going to be kind of a slower introduction that we're going to cover today. Okay. All right. So how many of you on your Macs here have FileZilla already installed on your machine? You have it now? Okay, good. So I'm gonna make sure that we map everything appropriately to the right inputs here, so that way you have everything you need to get started. Okay. All right. So when if you're using WinSCP, what you need to do is establish a connection to the cluster, right? And so all you need to do is fill in these things here, and then you'll be able to do that. So in this case, the host name is going to be rsvin.stat.tamu.edu, which is the same as the website. tamu.edu. Port number is 22. Don't change that. That's fine. Then your username, you'll have a username that's given to you for whenever you get an account, right? It may be different from your TamuNet ID. I have no idea. Okay. Whatever your username that's assigned to you is what you want to put here. And then your password is your Tamu password for your net ID, right? So nothing different here. Right. When you type in all that information, you hit login, and then you are in. All right. It's going to say continue connecting to an unknown server. Yes, that's fine. It's not unknown. Then it takes you here and it says a few things. This is for authorized use. Don't use it in any way that's going to violate any of the policies of acceptable use for the university, and then you're good to go. All right. So click continue, and then you're in. Okay. So let me pause here and just make sure that for those of you that are following along through FileZilla or WinSCP, that we're good to go. Okay. So for those of you using FileZilla in the room, I'm going to pull you first. Are you able to connect here?
Not really sure how the FileZilla, there's a lot going on.
All right, let me take a look. I'm going to floor around a little bit.
This is what pops up and that's I'm still open up.
Right, so now here's where you're going to put in all that same information. So if you're on FileZilla, you put the username, the password all in the top bar there. So you see it. Yep. Okay. Perfect. Yeah. So you should be able to see the file directory for the cluster on the right hand side. Got it. Yeah. Okay. So for those of them online, again, would you mind checking in with them just to see?
Yeah.
So if you're online, if you're able to see kind of on the right hand side of your screen the cluster directory, then you're doing good. So if you have any questions, go ahead and raise them up now. If you change to the root directory, you should be able to see all kinds of information, right? But the most important, the one we're going to spend the most time in, is the home directory. Okay, so you should be able to see that. So if you go to the home directory, right-hand side, you can see all of the usernames here. I'm going to click on mine, and then you'll see probably nothing if you haven't used it before, right? It should be clean, should be empty, but I'll pause here just to make sure we're all good. Everyone good? How about those of you online? Any problems, any questions? Well, now that I've hidden the Zoom window, I don't know how to get back to the chat. So let's see. Any idea? Have I broken it or is it still live?
Still,
Still good?
Yeah.
I
Okay,
think
all right.
we go up, maybe it appears. Zoom is very,
Maybe click on the Zoom. It will ask you to log in.
Yeah, it's asking me to log in, which I mean, I can sign in, so it's fine.
It's okay, everyone says it. Oops.
Everyone says it's good? Okay, all right. Are they seeing what I'm seeing? Are y'all seeing what I'm seeing online? Okay, good. All right. Now you can, on the right-hand side, this is the file system for the server, right? For the cluster. So this is how and where your information is stored whenever you run things. Now, if you haven't used the cluster before, you're not going to see any of the things that you see here, okay? These are private modules that are installed, that I installed myself on the cluster, right? But let me go back to here. Whenever you install our libraries and packages, right, it's going to appear into your home directory. right? So I'm gonna walk you through that process so that you know how to do it. But if you open up R, and you open up this, you will see the two different variants of R that's on the cluster that I've installed packages for. So I've worked with 4.3 and 4.4 on the cluster, so that's what you should see there, right? We'll go through the process of installing a package. So if you haven't done that before, no worries. And what I typically store in my home directory, and I would encourage you guys to do, is it's limited. Your home directory, 50 gigabytes, right? No more. It's backed up nightly. So that means that if you have some sensitive results that you want to make sure are backed up and protected, put them here. What I would encourage you to do is put all of your scripts that you're going to run in the home directory. Okay, where can I expand sign? So what you're going to see is these .sh files are the shell scripts that are used to run and execute jobs on the cluster. And the R scripts are the script that those shell scripts are calling that get executed on the cluster. So those are the two things I tend to keep in my home directory. And all of the results, the big results, right, tend to go into Scratch. So if you go over to the root directory here, you go down to Scratch, go to user, click on your username. I suppose you could look at others. I don't know if you have access to it though. So if I go to mine, you're going to see a lot of results, a lot more files. You get a lot of, right? So you get a lot more Scratch access. So I've described this all in the document that you see here. So let me scroll down here. One thing to mention, we are in the process of creating a portal, right, that will do all of this through the cluster. So you don't have to have a separate client to do that. Similar to how the HPRC has the open on-demand portal, but we're still working through the details of that. So for now, these clients will make your life easier.
So you're saying to run, save the scripts and run it in home directory and save the output in the Scratch.
Correct. So in your scripts, you can change your working directory to your Scratch folder and then save all of the big results there, right? Does that make sense? So and the reason is here. So you have 50 GBs for your home. It's backed up nightly. So what I use this for, and what I would encourage you to do is use it to store your scripts, any summary results you can put there, right? That's all fine. That's going to be backed up and protected. On your Scratch, you have much more space here. You have 200 gigs, right? It's not backed up regularly. So you need to move them out of the Scratch and put them somewhere else if you want to protect them. But it's really good for temporarily storing your data, especially when you're doing simulations. You want to generate the simulated data and then save the results. Then you can put all that in your Scratch. And once everything is done, then you can then transfer it to your local for long-term storage, right? You don't want to put everything in your home because you have a fixed amount of space there, right? So any questions about that? All right. So you can see what's in your Scratch by just navigating through these different directories here. Right? Make sense?
So there is a question in the chat.
Yeah.
So it says like, is this possible to access r7.stat.tamu.edu only under the TAMU Wi-Fi container?
Only under the TAMU Wi-Fi. Yeah. So if you're on the TAMU Wi-Fi or if you're on the TAMU network, you don't need to do anything else. You can directly do everything that we're just doing here. But if you're not on the TAMU Wi-Fi or on the TAMU network, that's when you have to do the intermediate step of the VPN. Okay, so you have to log into the VPN, make sure you're connected to their VPN, and then you can follow the same set of steps. And I put the VPN instructions for how to do that and how to install the client that you need in the doc here, so you can see it. Okay, very good. All right. Any questions about home, Scratch, how to see what's on it? Now, you want to upload files? Fine, right? This is why I encourage you to use these clients. Let me go to C drive. Go one up, please. Go to downloads. Take a look. So these are the files that I just had, right? So I can take this. If I go here and then on the right-hand side, I'm going to navigate to my home directory.
Only the cluster, right?
Right. On the right-hand side, I'm getting to the home directory in the cluster. And on the left-hand side is the local directory, right? So left-hand side is local directory, right-hand side is cluster. So I already have these scripts on the cluster, but let's say I wanted to upload it. It's drag and drop. Okay, FileZilla is the same way. Just take that, drag and drop it to the cluster, and then you'll have it. Okay. Same thing if you want to pull things off, right? Drag and drop. Let's say that you want to edit one of these files and you don't really want to go through the process of downloading and then re-uploading, right? That's okay. You can edit these in FileZilla and in WinSCP directly, right? So if I go to this editor, take a look. I can directly edit this file, save it, and all of that's done on the cluster, right? So the way that I got there goes is I can right-click on any of the files that I want to edit and hit the edit button. And it has an internal editor that you can use to modify the file directly. A lot of people use VS Code in a similar way. I haven't made the transition to VS Code yet, so I'm not going to speak to that. But if you're familiar with VS Code, there's probably an easier way to do it. Same thing for R scripts. You can edit these directly in their local editor. It's not as nice as RStudio, but nonetheless, it's still there. Okay, so in terms of getting things onto the cluster or off the cluster, any questions? Any concerns? For those of you in the workshop, are you able to transfer those files to your home directory? So if you take the files that I put on this drive, like in particular, the two shell scripts and the .r script, if you take those three files, download them to your local machine, and then use FileZilla or WinSCP to upload them to the cluster. So I want you to take a moment to do that, and then we'll continue. But I want to make sure that everyone has that ready to go. And Sanjay, if you could ask those on the chat just to let you know when they're done. Yeah, if you could just put in the chat for those of you in the online, when you've downloaded these files to your local, and then use either WinSCP or FileZilla to load it to the home directory in the cluster, then we'll continue.
This is just a general example of how to submit a job to cluster, like this SH file.
Yeah, we're going to look at the details of both of those files so you can see how I set them up and why I set them up that way. But I didn't get as far as I'd hoped to on this one, so I just have like one basic job set up for now. I'll probably do another workshop in the spring to do job arrays and dependencies for multiple job submissions. Things like that. Yeah. All right, all good. Anyone online having an issue? Let Sanjay know in the chat, please. Good?
Yeah, we are good.
Fantastic. Okay. Now let's go back to the document and just continue along here. So while you have a file client that makes it easier to transfer files, you're also going to want to access the cluster directly, and we're going to be using a command line interface to do that. Okay. So you have FileZilla or WinSCP to transfer files back and forth, totally fine. On the back end, it's using a command line interface. It's just giving you a nicer way to do that with a GUI. So what we need to do now is open up a command prompt in order to access the cluster in our own command line interface and do that. So if you're in a Windows machine, you have two options. You can use Windows PowerShell, or you can just use a straight up command prompt here. Either one, both of them work just fine. I'm going to use PowerShell. If you're on a Mac, you'll want to open up a terminal. Okay, same thing. So for those of you on the Mac side of the house, you'll open up a terminal. Okay. All right. Okay. So it should, let me see if I can make the screen a little bit bigger. Okay. Right, okay. It's like, that's better. Okay, all right, much better, right? Okay, now let's figure out how to log in. Okay, so these instructions are curated in the document that I provided you here, but they're also on the cluster's website. So if you need backup or if you need to go through this at another time after you have access to the cluster, if you don't already have it, you can do that. But we're gonna log in through SSH, right? So we're gonna do SSH, then your username at arsavan.stat.temp. Arsavan.stat. That is what you will type in for now. So I'll leave that on the screen. So go ahead and type that in, hit enter. All right. It's going to ask you, authenticity can't be established. So are you sure you want to continue connecting? It's fine. I promise that, that you'll be okay. All right. Okay. And then it's going to give the same warning about making sure to use the system in an appropriate manner that's acceptable use. And it's going to ask you for your password. All right. Now, when you put in your password, it's not going to show the little dots. It's just going to be blank, right? So it may look like you're not entering it in, but you are. So if I do put in my password, and then there you go. Okay. But while you're putting in your password, it's not going to do anything. So if you successfully logged in, you will see this very basic screen here. It reminds you that there are only nightly backups of user home directories. All right. So if you lose something important, we have nightly backups there. And it's reminding you that the preferred method of interacting with a cluster is using the srun sbatch commands. Okay. So then I'll show you what that is and how to execute it here.
I have a question.
Yeah.
So you said that Scratch directory is not backed up. And you should move also files to local if you want to save them. So is there like any frequency when the Scratch directory is cleaned or?
Oh, is it cleaned out?
Yeah.
I think that's a question for Matthew. So I would ask him about that. As far as I'm aware, that Scratch doesn't get cleaned out as long as you don't exceed the limit. So if you have a bunch of results for one paper, then you need to produce another big set of results for another paper, you may have to clean it out yourself. But as long as you're under that 200 gig limit, he's not going to touch it, right? But you may want to ask Matthew about more details about that to make sure. But I've had stuff in my Scratch that's been there for months and it hasn't been cleaned out. So at least from my own experience, it's not going to get touched.
Another question.
Yeah.
So it looks very similar to HPRC, right?
Yeah.
But in HPRC, we had a limit on like basically kind of tokens.
A limit on the
Basically like.
the number of
Number of
files.
nodes.
No, not no.
Hours,
Not hours. It's like 20,000. You get 20,000.
Yeah, service units.
Yeah,
Service units. Okay, very good.
Similar like this.
Okay, all right, great. I'm glad you're asking. All right, so very similar interface to HPRC. This differs in two very important ways. No service units. Okay, if there are available units, it will run. Okay, and number two, no annual reports, no requests. Right. Once you have access, you have access. All right. If there's a node that's available to run your job, it will run immediately. Otherwise, it'll get put in the queue. All right. So this removes all of the hurdles that let you use it. Okay. Any other questions? Very good. All right. Very good. So you can see the limitations of disk quotas, right? So in this case, I have a limit of 50 gigs and 200 gigs, and number of files is much higher, right? So plenty of issues there. Okay, so once you see this, you're on the cluster. You're on a head node, right? You're not on a compute node, right? So there are two machines in the cluster that are purely dedicated to just handling file management and logins and things like that. Okay, I think it's two. At the very least, there's one node that's purely dedicated to handling logins. Okay, now, do you see this on your screen? Show of hands. Feel good? No, you don't see it?
Wait, I have to wait to get access. I don't have the.
Ah,
yeah.
I see. You have access?
I thought.
No, okay, all right, okay. Well, it's all there for when you're running it. Those. Oh, I see. Yeah, no, yeah, this one will be a little bit different. Subject, or is everyone online okay? Those of you online, let Subject know in the chat if you have any issues, but I'm gonna continue unless I hear from him, okay? All right, so once you're on the node, once you're on the cluster, what are some things that you can do? All right, so this is all through here. All right, first and foremost, Modules, what are modules? When you're on the login node, you're on a machine, think about you're on a machine that has nothing on it. Okay, it has a basic system that can present what you're seeing here, but it doesn't have any software installed on it, okay, by default. So what you have to do first is if you want to be able to interact with R, in order to install packages, we need to install R effectively, right? So those come in the form of modules, okay? There are many modules that are built in that you can use. Many of them cover R, Python. I think we have some from MATLAB. There's many, right? But let's say that you wanted to install a package in R because you're planning on submitting a job that requires that package, okay? First, there are different versions of R that are available on the system. So if you type the command module, let's start with, I think, module avail, right? This provides you with a list of commands that you can use in order to see what's available to you, but I'm going to use just a subset of those. So if we type in module avail like this, we're going to get a lot of modules that are available. Okay, now you can see Anaconda is there, CUDA is there, FlexiBLOS, we have more. GCC is there, Jupyter Lab, and Ninja, OpenMPI, PyTorch, Python. Just keep hitting enter, it'll keep scrolling through. 412, you can see these are the modules related to R. Okay, so these are the names. We have 4.1, 4.2, and 4.3 and 4.4. Continue, very good. Okay, all right. Eventually, after you hit enter enough times, you'll be out of it. Okay, so this shows everything. Suppose you just wanted to find the ones that are relevant to R, relevant to your specific thing. What can you do? Right.
Some options. Can we use Conda?
Conda?
Yes.
In order to manage like Python packages?
All the packages.
So-
Conda.
We have Anaconda on the
Oh,
cluster,
yeah.
so you can load
And
that
it's
module.
missing.
Yeah, absolutely. So it has Anaconda, so that way you can just load that directly. If it doesn't have what you need, there are ways you can install kind of your own custom stuff, but that would be a question for Matthew, right? So that would be kind of beyond what the hope is that these modules will have 95% of what people need, right? And we can handle the other cases. Anyway, so if you wanted to find something specific to Anaconda, like your question, so you would do module spider. It's going to search through all the modules like a spider and find Anaconda. Okay, cool. So it's going to bring and describe the specific modules on there that are related to Anaconda. Okay, so this gives you this particular build, or this module has Anaconda 3. It describes what it has on it. And there's more information that it can give you. Very good. We only have one for Anaconda right now. So you can take a look and see if it works. Same thing we'll do for R. So in this case, let's say you wanted to figure out what modules are related to R. So here in this case, we have a few. Okay. These are different builds related to R. They have a lot of the packages already installed on them. So you may find that a lot of them are already available. But nonetheless, you may need to install additional ones yourself. Okay. Hit enter, and then we will continue. Okay, very good. So this will give you the names of the modules that you need to load. Okay. Once you've decided on the specific version of R you want to use, let's suppose that we wanted to use this one. Okay, so I'm just going to grab that, copy it, and I'm going to load it. Okay. Good practice to make sure that there are no other modules already loaded. So what you can do is you can do module list. No modules are loaded, right? So you don't need to do anything else. That means it's totally clean. If you want to get rid of all the currently installed modules, what you can do is you can type in module purge. That'll get rid of any modules that are installed and then remove them. Okay. So now we want to make sure we install the module that we need. So we do module load, and I tried to paste that. It was unsuccessful. So I'm just going to type it out. R 4.4.1 -GFGF. Okay. All right. So are you guys typing it? Okay. All right. Good.
What's the default R version?
There's different versions, so it's totally up to you.
I think, like I know you are gonna go to that as batch files.
Mhm.
Over there, we say like the, load R.
That module load command will appear in your shell script. So that is something you have to pass into the shell script and then run the R script. Yeah, so you get to decide whatever you think is appropriate. Sound good? All right. Anyone have any trouble so far? So when I hit enter, what does it do? Well, it makes R on that available on that machine, okay? Make sure I'm not getting ahead of myself in the tutorial here. Very good. Okay, yeah, so this one uses for, yeah, okay, very good. So now when I rerun module list, you're gonna see a bunch of stuff, okay? Module list. This H that you see here is hidden, okay? This module depends on other modules, all right? So there's a lot of other things that are installed. You can see GCC is in here, so that way you have access to OpenBLAS, FlexiBLAS, GCC in case you're doing C++ type of stuff. With the backend, it's already built in there, so you don't have to install that explicitly.
I had a question regarding the R version.
Yes,
So, the R version that is over here, 4.4.1,
yep.
that's a pretty old R version. So if we need a new R version, because some packages rely on,
And even,
Fine, okay, all right. So easiest way, send a ticket to Matt.
okay,
So the ArtSci help. Here. This one. Zoom in. artsci-help@tamu.edu. So the same one that you submit an access request for, send a request there. He will do one of two things. He will either make it available or he will tell you a way to do it yourself. So, okay, one of the two, right?
is it possible to make it available for everybody, like that? Let's say I requested because I need it, but somebody else need it, and then they also need to request,
This is where sending a ticket each time, even though it seems like you might be annoying, actually helps. Because if he sees a lot of tickets requesting the same version of R or something like that, that gives him the justification he needs to invest the time to make it available. Does that make sense?
Yes.
So don't be hesitant about sending one of these requests. That's the way that we gather information about what users need. Okay. Very good. Okay. All right, so you'll see that a lot of the modules are hidden because they're installed on the back end, but you do get. Okay, all right, very good. So now. Okay, so now we're on this. We're on the head node. We've installed. I just wanted to see the last one. But that's fine. We're on the head node and we have set it up where we have R on there. Way you access it. Little R. Hit enter. Look familiar? Okay, this is your R console. You can now interact with it in the same way that you would on your machine. You have a question?
No, I was happy.
Do you see it on yours?
Oh, yes.
Okay.
I know.
You see it on your machine? On your screens? I'm making sure, for those of you that have access, you should be following along, right? Okay, very good. All right, ready? What's a package that one of you needs for research that you're doing?
GLMN.
GLMnet, okay, all right.
so I'll just keep it.
Install.packages, GLMnet, same as you would, just like you would on your machine. Okay, now it's gonna ask you for a mirror, just like it would on your machine. 63, no, that's gonna take too long. Tennessee seems to be the closest.
Oh, that depends on something?
What?
The number you are putting, like the kind of.
That's the mirror where you're pulling it from. The closer it is, the quicker it's gonna be.
Oh, I didn't know that.
Yeah. Okay, all right.
It's good to know.
What's the closest one here?
The closest one I saw was Tennessee. All right, now, let's see. It's still going. It's installing a bunch of stuff. Okay, so give it some time.
Yeah, it must take a lot of time. Like,
It's a very nice example.
oh, those mirrors?
The mirrors, they're locations where you can pull the information from.
I see.
Yeah. Okay. Are we done? Looks like it. All right, very good. Okay. Now. There we go. Okay, all right. You can use this just like ARC. This is ARC. This is, you're on the login node. You can interact with this just like you would. So any packages you need to install, do it this way, right? You can just install it directly like this. Sound good? Okay. Now, what it does is it puts it in a temporary place. So let me go back to WinSCP and show you what's going on now. All right. So if I refresh this, I go into R, I go here, I go to 4.4, take a look. What's there? GLMnet. Okay. So it's installing it. When you do that, it may ask you some other questions. All right. Let me go through what I saw when I did this at home in preparation here. So after we did the file transfer, after we did that, after we did the install packages, this is what I saw from, okay. It says, I tried the tidyverse and it said, would you like to create a personal directory instead? How many of you saw this? You did it. Okay, very good. Hit yes, right? That puts it on your personal directory. No one else may need it. Would you like to create a personal library if you haven't already done so? You have to hit yes again. Okay, and then you're fine. Sound good? So now you have installed that for your own personal use whenever you run a job on the cluster, right? If you switch versions of R, just like you would on your machine, you have to install the packages again. Okay, so there's no magic there, right? It doesn't automatically transfer your packages. That's why when you look at WinSCP or you look on FileZilla, wherever you are, you have one directory for each version of R that you're working. Okay, so you have to install the packages this way. All right. Any questions? Helpful? Okay, good. All right, so now let's assume that you've installed all the packages that your heart desires. You're done with this, so you want to exit out of R, right? So now you just do Q, open close paren. You probably don't need to save your workspace image, so I'm going to hit no, and then that gets out of R. Okay, so now I'm back on my login node on the cluster, but I'm not in R now, right? I'm just back in the command line environment. Okay, so this is the way that you can then load the packages that you need. Sound good? Okay. I've already installed. So why don't you try it yourself? You'll need the tidyverse, okay, for the little sim script example that I've run. So why don't you go ahead and try it yourself? For those of you that are online, those of you in person, install tidyverse on whatever version of R that you chose. So take a moment to do that, and I'll float around the room and see if anyone needs help with it. Okay. Tidyverse, yeah. In other words, follow along with exercise 1, then you will do it. Okay. Exercise 1 is installing the tidyverse. So the reason I want you to do it yourself is I want you to get comfortable with this work because it can feel very foreign and very clunky and very complicated until you do it enough times. Guess good? You already installed it, or are you installing it?
Yeah.
Oh, you already installed it, you're good. Okay, how about on this, anyone else need it? Okay. We all have tidyverse installed? But, somebody, can you check with those online to see if they're working through exercise 1 or if they need more time? I don't want to rush it. Okay. The second part is installing from a tar file.
Yeah, I'm installed.
Installed it, perfect, okay, all right, let's cover the next and most common scenario. How many of you are developing packages for your current method that you're developing? Everyone, right? Okay, very good. So maybe you create your own package. Obviously, it's not available on CRAN yet, but you want to use it and run it on the cluster. Fair? Okay, what can you do? Make a tar.gz zip directory, load it to the cluster, and then you can install it from the tar file just like you would on your local. So let's do that. If you don't have one, so you can use your own if you have one, or you can use the one that I've put in the shared drive. This is one I developed for one of my older research projects that I just used for the sake of example. So what you want to do is first, let's go back to this one. All right, this is the home directory. So what you want to do is if you haven't done so already, take this file and copy it to your home directory on the cluster, right? It's fine, you can override it, not a problem. Right, okay. Very good. Now, we're gonna go back to our connection to the cluster. We're gonna open up R again, same thing, right? So open up R. All right, there it is. So we've just typed in capital R and then it'll bring it back up. And now we can install the package by pointing to it with this command, right? So now you specify where you saved it on the cluster. Repos is null, meaning that you want to pull everything from here and from the source. So this is how you install packages from source. This command is no different than what you run on your machine, right? The only difference is that we have to upload this tar file to the cluster first and then point to that directory within the directory of the cluster. So if I do that, I can't copy and paste that, seriously. Okay. Maybe I can. There it is. Okay. So if I type this out or I copy and paste it, whichever the case is, I can now run that and install it, right? I think I've already installed it, but nonetheless, it'll run again. So that command that you're looking for is right here. So once you're in R, what I want you to do is copy that command and then run it in order to install that module from the source file, okay? So this would be useful in a situation where you're developing a package, you have it on your local, it's not yet on CRAN because you haven't gone through all their hoops and hurdles in order to get it on CRAN, and you want to be able to work with it and install it on the cluster. Okay, so you would do it in this way.
I have a different kind of question. So can you make folders, subfolders using FileZilla, or you need to use
Yeah, no, absolutely. So you can make subdirectories here, right? So if I do new directory. Yeah, so if you want to make a new subfolder within your home directory, you should be able to do it using their interface. Here you can create a new directory just like this, right? So I do give it a name. And there it is. Yeah.
It's the same for files.
It should be the same for FileZilla. If you right click somewhere in there, let me take a look and see.
it's
Okay,
Says create directory.
yeah, you can create a directory, give it whatever name you want for that directory, and it should be good to go. So this is just a nice way to deal with the file systems and moving things around without having to use command lines interface. Okay. Okay. So hopefully it's installed, right? Okay, very good. So then we do library, PPA, CPP. You can see I can load it, no problem, right? So this now makes it available for any script that you run on that particular module, right? Again, this is module specific. If you load a different module that doesn't have that installed, then it's not going to run. Okay. Sound good? Okay, so let's exit out of R now once you're done with that. So Q paren workspace. I'm back on the login. Right. Let's see what we have next. Okay, now, so at this point, where are you in your cluster journey? You've gone from nothing. Now you have a way of transferring files. That's great. We have a way of installing packages that we need. Also great. And now we're at a point where we have a script that we want to run on the cluster. Right? Okay. So that's kind of where we are in our journey. First, you want to make sure and look at the cluster and see what's the current utilization look like. That'll tell you potentially how long you have to wait for your job to run. Okay. So you can use a lot of Slurm commands. Slurm is the job scheduler that the cluster uses. It's the same one that the HPRC uses. So the commands that you run here are going to look and feel almost exactly like what you would use for the HPRC. So this allows you to transfer your understanding, your scripts, and run them in both places without making many changes at all. You would need to change the modules to reflect their modules and not ours. But other than that, the commands and the shell scripts are the same. Okay. So let's just run a few of these commands to see what you can do. All right. So the first command that we have is sinfo. All right. That's going to tell you information about the cluster. All right. So you can see the different partitions of the cluster. These are important because they determine how long of a job you can submit. If you exceed these time limits, your job will not run and it will wait in the queue forever. Okay. So if you have a job that takes more than 2 hours, don't send it to the short queue, right? Send it to the appropriate partition or queue that matches the time limit. This is job size, how many jobs you can have running. These are the nodes and the CPUs, okay? We have 12 nodes altogether that are CPU only. We have 3 nodes that are CPU and GPU. So that's why you see 12 on these queues and then 3 over here, okay? This AIoT, what is all that? That is, these are in use, right? Pull down here so you can see. Allocated. The A is for allocated. That's what I was. That means they're being used, okay? So right now we have about 7 nodes being used of the 12 CPU only nodes, and we have all 3 of the GPU nodes are fully available right now, okay? 5 are inactive or idle or ready to be used, and none are other, okay? Other, I don't even know what constitute that, don't worry about it. This is your total, okay? Now, at times, you're going to look at this, and this number is going to be 12 across the board, and this number is going to be 3 across the board. Actually, all of the GPU nodes are being used, right? Because this is 3 that are allocated, 0 or idle, okay? So you may look at that and say, what the heck? Does that mean I can't use the GPU nodes? No, not so fast, right? Remember, Slurm doesn't require 1 user per node, right? It allocates the jobs based on the available resources. So even though the GPU nodes are in use, take a look. 257 of the cores or the CPUs across those 3 nodes are being used. 127 are idle, right? So even though the GPU nodes are currently being used for some job, there are still available resources that you can use, right? You have 127 of the CPU cores that can be used out of 384 total, okay? So as long as there's enough memory and there's CPUs available, your job can still execute, even if the node shows as being allocated. Okay, does that make sense?
You check the memory.
How do you check the memory for these jobs? I was looking for that when I was preparing for this workshop and I couldn't find it. So that's something that I'll have to follow up on. All right, so let me add something to the workshop and I'll
Like the running jobs are, how much memory they are, taking?
I'll check the memory allocation. So in other words, how much memory is left that can be used,
Yes.
because that's also the second part, right? How to check memory allocation across nodes. This is TBD. All right, I'll update that later once I have an answer for you, Shi. Okay. All right, yeah. But for now, this allows you to see, at least at the very least, are there CPUs available, right? And this is also why when you submit a job request, make sure that you don't way overshoot your required resources, right? Because if you say I need a terabyte of memory and I need 500 cores, you may be waiting for some time for those resources to free up, right? So if you can more appropriately tailor the number of cores, the amount of memory, and the time to better fit your job, it's going to run faster and quicker because it's going to be able to allocate those resources. Okay. All right. Now I don't have, and that's for another workshop, is how to check, what's it? Yeah. How to figure out how much CPU a job requires, right? So that's setting those is important, not a part of this workshop, right? So if you want to figure out how many CPUs your job needs, that's usually pretty easy because it depends on how many things you're doing in parallel, right? But if I'm trying to figure out memory allocation, if I'm trying to figure out timing, it's a little bit more difficult, right? So there's functionality on the HPRC. It's called the job stats function that you can use in order to check that for completed jobs. They're using something that Matthew doesn't really feel comfortable moving over to our system. So we're working on getting another function that will give you visibility into that. Okay, so just sit tight on that. It'll still be some sort of a job stats command that you can run to say this job use this much of the CPU and use this much of the memory, right? So that way you can then test out jobs and then plan your future jobs more appropriately, right? But we're still working on that functionality. Sound good? Okay, all right, very good. Okay, so let's say you can see that we have some resources that are free. Let's see if you want to see what's in the queue. You do SQ. Okay, all right. Here is the queue as it stands right now. So you'll see each one of the jobs that are waiting to be executed, okay? All right, and it gives you some information about it. The job ID, the name of the job, the user, the partition that you're requesting, how many nodes, how many CPUs, right? This is good, you're requesting 100. The state of that job is, what is it, pending, right? Pending here. This one is running, sorry, it's kind of cut across the screen. Right, so all these are running jobs, these are pending jobs, and you can see the time left, the start time, and the reason if it's still in the queue, what it's waiting for. So you can see that this first job here is, whose job is that? Okay, and so that job is waiting for resources because there's not enough resources right now to allocate it, right? One thing you'll want to check here is whatever time that you've requested, make sure that it is within the limitations of the queue. So the long queue, like for this job, let's see, where does it go? You scroll down here. The long queue, and this is on the website if you need to see where these can be found under the documentation, can accept jobs up to 7 days long. Okay, so that's fine. If you specify the long queue and then you specify a 10-day job or a 10-day time limit, it's not going to run. It's going to say it's waiting for resources forever, right? And it's not going to tell you that you misspecified it, right? So just be careful. I think the default is the medium queue. It's the short one by default. So that's only 2 hours, right? So make sure that you specify the right partition for the time limit that you need, okay? If this is the maximum time, so, and we'll see that in the batch script, you have to specify the maximum time that job is going to run. And once it hits that level, whether your job's done or not, it kills the job, right? So you want to make sure to specify it correctly and make sure that you give it enough time for the job to complete, but also put some safeguards in place in your code so that even if it runs out of time, you still get some results and you don't lose everything, okay? So I've set up the script in order to do one way in order to do that.
Sorry, go ahead.
So what do we specify when we choose nodes? So
You will go through the shell script that'll specify each one of these. So you have to specify the partition that you're going to use, and you specify the max time, right? The time limit for your job. And you specify the number of cores, the amount of memory, all of these things you specify. Yeah.
So is it a good practice to maybe just specify your partition as something that is more than what you probably would need?
Yeah. So
Because it's gonna end within that time. Say I need maybe 7 hours.
Yeah.
And I mention it to be long
Mhm.
and just specify that the maximum time is 5 days. Because
Okay.
you never know
Sure. So the question is a very good one. So why, when would you, so if you overshoot it tremendously,
Mhm.
the risk you run, pros and cons, is that you may be waiting in the queue, waiting for resources to be allocated because you've requested 5 days worth of runtime, right? So, and then ultimately your job will probably take less than that. So once it's allocated, it'll take however long it takes and then it's done. But when your job says 5 days, that means that if I submit a job, it's looking at your job thinking that it's going to need it for 5 full days. So it may hold up other people's jobs because it has to allocate that for the 5 days.
Okay, so it also looks at the time that you're requesting for not only the available resources in terms of CPUs and memory.
Yeah, so that, what that means is that, so let's say you submit your job 5 days and it runs. That means that that part, those resources are going to be blocked off for 5 days. So anyone submitting a job it's going to show those as blocked off for the full 5 days. So it may cause inefficiency in the network, right? Because then other people's jobs that could have been scheduled, if there was resources available, would have to wait.
Okay.
Right. So it's good to overestimate certainly, but not dramatically, right? Yeah. So that's typical. And then you can set up your jobs in a way that saves the data as you go, so that even if it hits the wall time and kills it, whatever replications you ran up until that point, you still have, and you're not going to lose those. So then if you need to, you can just kick it off again and let it continue, right? So I'll show you what that looks like here. Any other questions? Good. All right. Okay. Yep, checking your queue. If you want to see if the queue can get pretty long sometimes if people have a lot of jobs in the queue. If you want to see just the jobs in the queue that correspond to you, you can just do SQ space -U, then your username, and it will show you only the jobs in the queue that correspond to your username. Very good. If you want to see a lot more of the examples of the Slurm commands that can help you see what's going on with the cluster and things like that, you can look at this quick start guide that's available. All of them are going to be. Okay, so now we're at a point where we can actually submit a job. Okay, right. So now we're going to get into the shell script. We're going to look at that and see all the different inputs you have to specify, and then also what the script is that we're trying to run. Okay. So again, this is the preferred usage for running large-scale simulations. So if you need to submit a job that's going to take a long time or use a lot of computing resources, using SBatch is the way to go. So for now, let's just open up the SimScript one, and I'll show you how I set it up and why I set it up that way. Let's go to this one. And we're going to open up SimScript1.r. If you haven't already moved it into your home directory on the cluster, do that now. And then we're going to take a look at it. Okay. All right. Can everyone see it okay? Hopefully you can see it on your screen. Any questions here? Okay. So I've set it up in a very specific way. So let me go through line by line. So I'm just removing any of the objects that may be there. All right. So that way it's a totally clean space. Installing any libraries or loading any libraries that I need, totally fine. Setting your working directory. This is where you can point to your Scratch space, right? So this way, any results that you save go to your Scratch space, all right? So that way you have lots of room and you don't have to worry about memory limitations within reason. Now, in this case, I'm assuming that most of you are going to be doing simulations that require you to run through doing the same thing over and over, right? I have 100 replications. I'm simulating a random draw from some process. I'm applying the method that I've developed, getting some results, and then storing those and repeating that process over and over again. Does that make sense? Does that fall in line with most of the things that you guys are doing in your scripts? Fair? For simulations, you're simulating the data, but you have to simulate it multiple times for different realizations. Apply your method, store the results, right? Yeah.
For my application, I have a lot of genotype data that I for sort of access speed reasons, like to put into list format, and if possible, because I don't know what type of memory use that would be if I try to do something parallel, accessing some 5 GB object
Yeah.
100 times.
Yeah.
Like just creating a folder directory that I can use like data tables, read write functions from.
Okay, yes,
So if I already do that, then I would have like 5 GB folder directory that I would need to put into the Scratch directory. So upload it to here, so I can access it that way.
you mean, so you have a data set that you're pulling from?
Yeah.
That in order to then, you doing some subsampling or something like that, or how?
Kind of, yeah, so I just need to operate a function over
How big is the file?
several gigabytes.
Several gigabytes. That's doable. So what you can do is you can upload that directly to your Scratch, and then you can create whatever subdirectories you need to operate. So all of that can be done through. When
I
it's
know like pushing individual files is relatively straightforward. What about like whole folders? That
so
might hold broken apart in a sense.
so you have those folders on your local?
Yeah.
So you can drag and drop. Yeah, so any folder you have on your local, you just pick up the whole folder itself and then drop it over here, and it'll copy it as this, yeah. So that's true for FileZilla or WinSCP, whatever. Okay. Very good. So then. Okay, very good. So let's go back to the script just to make sure it makes sense for what it is. All right. So what I've done here is I've set the seed. Pretty standard. Now, since I'm doing 100 runs, what I'm doing now is I've done this in the past and it's worked pretty well, is I create a seed list. All right. Because I'm doing random draws in order to generate the process each time, I'm just storing those seeds at the beginning. Okay. In a CSV. The reason I'm doing that is because if my job gets killed for whatever reason, I can always go back to this seed list, pick up and keep going, right? So this protects me in the case that the job fails due to a node failure, hitting memory limits, hitting time limits, whatever the case is, right? Okay. So I can write that and I can write that to my Scratch directory, no problem. And then I initialize the matrix that's going to contain my results. This could be a list, matrix, whatever the case is. Then you're looping through all of your replicates and doing something, right? You could easily parallelize this code in R. That's totally fine. No issues there, but I haven't produced a working example of that just yet. That's for a future workshop. Well, let's suppose that you're going over your replicates. Each one of those, I'm setting a seed. Why? Because I'm generating a random draw of my data and then applying the method. Okay, so I can set seed here within the loop. So that way, if my job gets killed and I need to pick up from the 67th iteration, I can just directly pull the seed list, start from iteration 67 and continue. So I can rerun my job, picking up where I left. Okay, so this is a way of checkpointing to make sure that if your job gets killed, you still have some results that you can pull from. So I save the results in I, and within the loop, I'm saving this to an R data file. So that means every time I go through the loop, I'm saving and I'm overriding. Okay, this will make sure that, again, if my job gets killed, I still have an R data file that has most, if not all, of my results. Make sense? So this is one way in order to protect yourself in case you misspecify the memory allocation, your job runs out of memory, or you underestimate the time. So even if you underestimate it, it gets killed, you still have a large number of your replicates that are still there.
Can this be done in parallel as well?
The saving, yeah, that's totally fine. Yeah, I've done this similar construct within a parallel setting. Yeah, so that's not a problem. I'll see if I can construct for another workshop later on, like an example with parallel and saving in parallel. But I've done that in the past and it seems to work just fine. Right? I know that they're all using different cores and saving at the same time. Very rarely does it error out. The only time it would is if both of them are trying to save the same object exactly at the same time. That rarely happens, right? So anyways,
It depends on how long it takes to save. Yeah.
that too. If it's pretty big, it can cause problems too. Yeah. So I'll take a look and see if I can come up with some examples of scripts like that, but this should work. The other way to handle it is through job arrays, which I think is another way that's good to go about it. But again, later, another workshop later on. Okay. Any issues here? Make sense? So all you need to add to the cluster is a script that can be run top to bottom, right? So the assumption is I'm just going to call this script, run it from top to bottom. And it's going to save everything that I want to be saved. Okay. So that's the assumption. That's what we're doing here.
I just have a question. So sometimes parallel computing stuff seems to differ between Mac and Windows computers. How are we supposed to write our files?
Oh, you mean like in terms of they can differ with respect to how you call it, and how you do it. That's
Like,
where
I can't check number of cores on a Mac computer the same way, like a Windows computer the same way that I do a Mac. So like if I accidentally upload a file, it's like 10 cores, I think it stuff to do its job, right?
yeah, that's just going to require some testing on the system. So this is where the interactive jobs may be helpful because I'm going to show. Hopefully, I have time for it. Yeah, we'll have time for it. To do an interactive job where you can open up an RStudio session on the cluster and then you can create the script itself. So that way it'll allow you to do that. Very good. Okay. But if you already have a script that can be run from top to bottom and you just want to execute it, then we're on to the next step. So what we need, go to the directory. Now, the only thing we need to add to this is a shell script that will tell the cluster and Slurm what resources are required and what you want it to do to run that script. So now let's go to simscript1.sh or shell file. Okay. This has a lot of commentary and documentation, so it's much longer than it actually needs to be, but it provides some explanation of the different inputs, what you are seeing. I make the font any larger. Okay. All right.
So there are some comments from Isaac on the chat.
Yeah.
So he says that it's safer to use a fork process model if you are saving files in parallel from a single R script rather than multi-core. And in general, Linux will support the parallel models from all backends.
Yeah.
Mac OS doesn't natively support OpenMP. Windows doesn't natively support pthreads, and MPI implementation is 40 for both.
Yeah.
All of these should work on it.
Okay, very good. Thank you, Isaac. He's a very advanced user that has very comprehensive knowledge of these things. So
Did you copy that from the chat? And somehow, email us lots of documents of this house.
and Isaac, I may tap you in order to come up with a good example for parallelization if you're on the chat and are willing. So that would be helpful. Okay. All right. Very good. So let's go through some of the inputs here that you need. Don't modify this. All right. This just comes with every bash script here. Okay. Now, everything you see that's hash sbash is telling Slurm about the requirements that are needed to run your job. So in this case, we can give it a name. So I've just given it a name that I can identify it from the output in SQ. So this will allow me to see which job I'm running. That way I can see if it's allocated or not. I determined three things here. One is the number of nodes I want, the number of processes I want to run on that node, and how many CPUs I want. So if you're running a parallel job, this obviously needs to be greater than 1. Okay, all right. But that's if you're doing the parallelization within R. Okay, so then you'll want to increase that to match the number of parallel jobs you are running.
Difference between nodes and tasks.
Right, nodes are the actual nodes on the cluster. Tasks are processes running on that, right? So I may have one instance of R running, I may have another instance of R running. Those are different tasks, right?
So
Most of the time you would just use one task.
Is it like different settings?
It's like different instances of R, right? You have R, you can run multiple instances of that, right? Yeah, so most of the time I just use one node, one task.
When do you use one node, multiple tasks?
I'd have to figure that out, right? So that would be a Matthew question, and or I could come up with some examples of that. Yeah.
Yeah, actually, I have similar question. So suppose I want to run, say, 200, a loop with 200 in parallel. So then, shall I actually write n nodes to be 1 and number of CPUs per task to be 200?
Right. So okay. So let me make sure I understand it. So you have an R script
Yes.
that is parallelized, meaning you're using what, for each, something like that?
Yes, it's for each, and it will detect cores, and then it will say, for example, it will run over all possible cores it detected, because in for each actually we usually detect cores first, now what are the number of cores, and then parallelize over those.
Right, okay, so right, so that means that you would have one node, one task, and CPUs per task would be larger, right? Each node has 128 cores, so you should avoid setting that larger than 128, right?
Yeah, so then I should put CPUs per task to be 128.
128, that'll use all of the cores on the node here, right? So that you can do. So that way it'll run in parallel. And if you have the detect cores, it will use all of those.
And suppose I want to do, say for example, I want to like say I want to do 200 instances, and in that case, like if I just put CPUs per task say 100, then so is this like will do 2 times, like first 100 and then it will again do second
Correct.
100?
So if you have to do 200 replicates and you specify 100 CPUs per core, it's just going to kick off 100 of those jobs simultaneously. When those complete, as those complete and the resources free up, it'll then start on the next batch. So it's just like having a machine that has 100 cores on it. Even if you specify in parallel, I want to do, it's only going to detect those 100 cores. So if you specify 200 jobs, it'll do those as it's available to do it.
And if I just do nodes to be 2 and specify CPUs per task to be 100, then would it do like full parallelization, for example, like
So that's if you still have one task, because that's CPUs per task.
Yeah.
So task is one,
task is 1.
then that means you only have one R processor. Right?
Okay, so in that case, like, I mean, if I want to do 200 simultaneously or in parallel,
Yeah.
then what to do? Because I can actually at most do 128 by this way, right?
So that's my current understanding. I could be wrong on that, right? That would be a Matthew question to see if you can bring together multiple nodes or something like that. That I don't know. Job arrays would be the way to go. So you can kick off many jobs in parallel. They can be split across all the nodes in the system, and you can kick off 200 simultaneously, right? So that way, but in that instance, the parallelization is not done in R. It's done through job arrays, through Slurm, right? So you would have a job script that does one of those jobs, and it would probably provide some sort of input for the seed. And then you would then use job arrays through this script in order to kick off 200 of those.
Then actually this for each will not help in that case.
No.
So I
In
have
that
to
case,
separately actually submit all of those.
But you can do it all through one shell script is what I'm getting at. So you don't need to specify 200 different
Okay.
shell scripts and kick it off
Okay,
200 different times. No, yeah, job arrays will allow you to kick those off simultaneously with one SBatch call, with one shell script. Okay, yeah, but that's on a future work.
So in addition to that, Isaac has an expert opinion on this question.
Please do, yeah. Please,
So he
please.
says like, if you have code which is inherently single-threaded or sequential MCMC perhaps, that doesn't use much memory for each chain, you could run 10 chains in parallel, each has their own task, maybe with 4 CPUs per task if they have some weak parallel scaling. Tasks are node bounded. One task can use multiple CPUs, but a single task will always be bound to CPUs on the same node. Okay, that's what he says.
I should just give Isaac write access to my my doc. Let me see. Then that way he can add these things directly. Thank you, Isaac, for that. Yeah, it's very helpful. All right, let's keep going. Okay, so after I specify these, you specify the wall time. So in this case, I'm only specifying 10 minutes. All right, but this needs to be an upper bound. Okay, once it hits this limit, your job is killed. So make sure that it will provide you enough time to run your job. This is where you specify the partition. So in this case, I've explicitly said I want the short queue. All right, by default, it goes to the short queue. And the limit for the short queue, let's see, is not very large. 2 hours, yeah, that's right. So if it's 2 hours, right, then, and you specify something longer than 2 hours and you don't specify the partition, you're out of luck, okay? So just make sure that your time and your partition are within the right ranges. Okay. You can specify memory in one of two ways. This double hash means this is not the one that's in effect. You can specify it as memory per CPU if you want to specify it for however many CPUs you're running, or you can just specify the total memory. So in this case, I'm asking for 1 gig of memory, right? It needs to be much bigger in most cases, but this is fine for this small little example. Very good. Okay. All right. If you want access to the GPU nodes, then you would have to make this option in play. This is going to tell it that it wants access to the GPU. Okay. You would also need to make sure that you're going to the GPU partition as well. Okay. All right. This one is the output file. So if there's anything that's output from your code, if you're printing any of the output, or you want to get a summary of when it's done or as it progresses, you can do that. If you look at the script that we put together, it's printing out some results when it's done. So you can save that here. This %J just says attach the job number to it. So that way I can reference it. Okay. All right. Mail type is equal to all. Don't change that. You can add your email address. All right. This way you don't have to sit and wait. Right. It'll send you an email when your job is beginning, and it'll send you an email when it's completed. So that way you don't have to wait. And it does it for each job that you submit.
Send it to any email.
Temu works. I think it should be an email, but you can test it and let me know. I think it should be fine. If there's somebody that you don't like, I guess you could spam their email too with lots of these jobs. So just be careful. Okay. All right. Very good. Else is there? Lots of details, but I'm going to skip over all that. These are the relevant parts after you specify that. So we've already specified through Slurm the resources that we need for our job, right? Memory, CPUs, all that, time, all that. This is where you have to add something that's not SBatch. Notice everything else that's prefaced by hash SBatch is telling Slurm the resources that are needed. This is what you want it to do within that system, okay? 3 things. Get rid of any modules that are currently loaded. There shouldn't be any, but it's good practice to put it there. And load the module that you want. And our script, run the script, right? So that's what it's doing. So it's saying, get rid of any modules that are loaded, load the one that I want. You can add multiple loads if you need multiple modules there, and then run the script. Our script, point to where the script is located, and you're done.
You're purging the module, will that get rid of installed packages? When do you reinstall?
The purged modules just gets rid of any modules that may or may not, that may be installed, right? Your packages are still going to be there for the module that you are loading. So if you previously installed the packages on this particular module, then you're good, right? It's still going to be there. Purging the module just gets rid of the module. It doesn't change anything about the packages on that module.
In interest of the module on the node.
Right. So on the compute node that you're requesting access to, it's going to get rid of any modules that are currently installed and load the one that you want. Yeah. So if you previously installed packages for this 4.4.1 version of R, they'll be available on that computer. Okay. Yeah. So once we have both of these, then what can we do?
Question, just the basic memory allocation
Yeah.
issue. So, say for example, you said that there are 2 ways of specifying the amount of memory that you are requesting, right?
Yeah.
Per CPU and in total. So for the in total memory, for example, so if I specify 4 GB of memory, and I'm doing maybe 100 tasks in parallel. So is my understanding correct? So if the first task that finishes is utilizing maybe 500 MB of memory to save the output or something like that, for example, then all the other 999 have 3.5 gigs of memory left to do the process that is required.
That gets into memory allocation with R and the parallelization, right?
Okay,
So that would be a Matthew or maybe an Isaac question. Okay, so because that gets into things about the structure that I'm less familiar with, right? This just gets into whether you're specifying the amount of memory as per CPU or for the whole job. Yeah.
okay.
But in terms of, if you're interested in like, how is the memory allocated per CPU for these jobs? That would be a Matthew question. But if it's more about R, that would be, yeah.
So what is the maximum memory available?
So each node has, I think, about a terabyte. Let me look on the. Let me look on the details on the website. System provides this. Each of the nodes have 1 terabyte of memory. Yeah, so, right, so it's pretty substantial. So if you have a job that's already using all of the cores, then you have access to 1 terabyte of memory if you need it. Yeah, okay.
So 1 terabyte per node or 1 terabyte?
Per node. Yeah, per node. Yeah, so it's pretty substantial. All right.
How to understand that you're utilizing resources efficiently?
Very good question. This is where the job stats function and SF is another Slurm command that you can use. There's been some issues with SF in terms of it reporting the usage correctly, but we're working on getting a package and a function that can tell you more correctly about the usage. In some jobs, it works just fine. SF does. SEFF for efficiency, but for other jobs, it's just wrong. So we're currently working through some of those issues.
It's fine, I think, if it's a running. It also mentions that for running jobs, it might be not the correct.
Right, but even SF for some of the jobs for completed is not returning correct. Isaac's encountered this, so that's fine. But for most of the jobs, I think the SF can tell you about, for a completed job, how much of the memory and CPU is using, right? But this is where testing on your local machine can help, right? It can make sure to give you a sense of the amount of CPU that it's using and things like that. But if you want to test it on the cluster as well, I would use SF. Let me see if I can find that Slurm command. Slurm is. Where is it? Where's just the Slurm documentation? Yes, I'll just go here. Right, use this command, SF, and then the name, the ID for the job. And once it's a completed job that's run, you can get information about the usage of memory and things like that. Okay. So just be aware that it may not return something reasonable in some of the jobs. Like it will say 0, the memory is used or things like that.
I just feel that there's something to be done.
Okay. All right, so
I have a question on, so there are potentially several, I guess, scripts, different people that you're running on the same node, right? Access to the same computer, same friend. If they don't have access to the same RAM, do like garbage collection captions from like one script affect the other one as well.
good. I'm going to give you my high level understanding, and details would be a Matthew question for IT. But the reason we're using Slurm versus the old configuration on the old system is because Slurm will separate out the job so that one running is not going to affect the others, right? So what you do in your script should not affect what's going on with anyone else's run, even if it's running on the same node. So I don't think that it's going to, because once that memory is allocated for one job, I don't think it can be used or shared for other jobs.
Because you're not sharing the same cores.
Correct.
So this might be I guess, is it like there's a fixed amount of memory per core, or is it like just somehow 1 terabyte available for every single core?
It's 1 terabyte that's available for that node. right? But it can be partitioned for different jobs as appropriate. So if I'm only using 5 cores and I only need 5 gigs of RAM, that means the other cores can use the rest of that RAM for other jobs, right? Yeah, so, but if you want a detailed kind of understanding of the sharing of memories and stuff like that, I think we'd have to get Matthew in here to address that. Okay. All right, so now you have these 2 files and you want to run it, right? So we've already looked at this. We've already looked at the job script. Any questions on those 2 things? Okay, already talked about partitions. Very good. Okay, are you ready to run it? No. Okay, is anyone following along and doing what we're doing here? If you are, sbatch simscript1.sh. So when you run this, it's going to run that script. So we can just do it and then see what happens. You can see that I have a job ID here. If I do SQ under my name, I'm going to see that job is running, which is great. If you check your email, you'll get a notification through email that that's running. If you haven't changed that email, I think it will send me the email. So please change the email to your email address. But nonetheless, here we are. So you can see information, it's running, it's on the short queue, it's there. Let's see. All right, now it's done. Now you can see it's not in the queue anymore, right? So I can do S account or SACC will tell me information about some completed jobs there. And you can see that this last one that I just ran, I think is, what is it, 526018. You can see that that one is completed now, right? So I can see that the job is done. And now I can get some of the output. Let's take a look at what this job produces so you can see how to use it. So if I go here and I refresh in the home directory, you're now going to see the output here. This is an output file. I can open it and I can see this is not me download it first. Let me just open it. No, it's not. One more try. All right, so this is the file, right? So this is the output that you get from R in your console for that job. So it gets saved into a separate file so that you can monitor it and make sure it's working correct. You can see here that I loaded tidyverse, so it's giving me all that information, and then it's printing out the results. So if you want to see if your job runs and you want to see when it stops running, if it gets killed, you can output the counter, something like that, right? But this will allow you to see information about your job that you want to see. So you can print out anything that you want and see it here. Okay. What else can you see? So we go to the Scratch folder. Scratch. What can you see? User. You can see this results R data file is the results file that saves everything. So now if I want to pull it down and then look at it on my local, just move it over, right? So everything is there and I can save it. If you want to take a look at it, while you're on the cluster, that's fine. You're on the head node, right? We can just do R and then I can load it. Let's see. Look at my work. That needs to change, so I can do load Scratch user, say Bruce, what's it called? Results, R data. Right, so I can do LS. Right, these are the 2 objects that I saved. I can take a look at them and see results and check them out to see if they're good, right? Yeah, so that's that data file is the one that I was saving, right? As we go. So that's how you can check it, right? So all of that is there. When if you're satisfied with the results, you can pull them down, do whatever you want, right? Okay. Sound good? So that's submitting a job through SBatch, right? Any questions on that? How many of you want to use it in an interactive session? You'd want to fire up RStudio where the computing is actually being done on the cluster, right?
It would be great.
Okay, all right, let's demo it. All right, I already have that. I have that loaded up and I think we have enough time to get through it, okay? The way it's set up right now is a little bit clunky because there's a security issue doing it the more direct route that again, kudos to Isaac because he found that. So, so now we have a workaround that gets us a more secure way of accessing it, okay? All right, so let's go through that. So where are we in the tutorial? We're here. Kicks off the job on the cluster. Once it's complete, you get an email and then you can check the output. Very good. Okay. Oh, one more thing. If you have a job that's taking too long, or if you realize you made a mistake and you don't want that job to run anymore, cancel it. All you have to do is do scancel -F and then the job ID. All right. So that'll cancel the job. So if you say, oh, I submitted a job, but I forgot to change one parameter or the simulation setting is wrong and I need to cancel it and rerun it. You can cancel jobs pretty easily this way. Okay, interactive jobs, let's do it. So let's say you want to use the cluster's resources, but you want to do some interactive development, okay? You can specify this for a fixed amount of time in the following exercise, all right? So if you haven't already, you take that interactive job script, transfer it over to your home directory. So you can see interactive job script.sh here. Let's take a look at it so you can see what's going on. You may need to change some of these. All right. So this one is a lot simpler because I've cleaned out a lot of the comments, but nonetheless, everything is here. So you specify the time. In this case, I'm only specifying 1 hour, right? You can adjust this, right? But I would recommend just doing this no more than like a day, right? If you're only planning on working on it for the full day, you want to have access to it, just do 8 hours, whatever it is, right? That way it'll get killed at the end of that wall time. All right, that doesn't mean you're going to lose your files. It just means you lose your access to RStudio and you have to rerun the job to get access to it again. All right, you can specify the number of nodes, 1 node, number of tasks, 1 instance of the server, 1 instance of RStudio here. You can specify the number of CPUs and the memory that you need for the job, right? So this is a bit light. It's only 4 CPUs and 8 gigs of memory. They want to increase this slightly, 1632, right? Yeah, gigs of memory and around 10 CPUs for a standard machine, right? But you can increase this as you need. Partition, I'm using the short partition because my job is less than 2 hours. Right? Okay. But you can change that as well. If you need GPUs, you need to tell them that you need GPUs, right? This is double hash, so this is not active. But if you need access to the GPUs, you can specify that here. And this output file is what you're going to need to log into RStudio. So you need to keep that there. Okay. You don't need to change anything here. Purge all the modules that are there before, load RStudio server, and then you'll follow the instructions in the tutorial in order to get access to it, right? Okay. It says the login credentials that you need to log into RStudio are in the server.output.jobid file. And after the job launches, you can take a look at that file to figure out how to get into RStudio. So let's do that. So I'm going to close this out. Any questions about the job script itself? So you'll need to modify this to match whatever requirements you need for your development.
Can you track the jobs for long partitions, or is it only medium? Because I think it didn't run when I used long or something.
I'm not aware of any limitations about the partition. I think it should be fine, but you can look at the reason. Maybe it's waiting on resources, right? So it could just be that it's in the queue when it doesn't have any resources to allocate.
Here, these modules container RStudio, is this part something will be common for everyone?
Yes, this is common for everyone. It's using this particular RStudio. Yeah.
Okay.
Exactly.
And is this already available, or we have to create this?
That's already available.
Oh.
Yeah, you don't need to do anything else. I'll actually show you here how to run it. So no issues there. So if I go here, I'm gonna kick off this script just like I did my other batch script, right? So I just take this interactive job script 1, and I'm gonna use sbatch to kick it off, just the same way that I did before. Sbatch. Job script 1.sh. Okay, there's my job ID 526025. We look at the queue for me and see if it's running. It is. That's good. So now what should I do? All right, this is where the instructions you have to follow carefully. Okay. So in your home directory, there's going to be a new file that's output, and it's going to have this with the job ID here. All right, so let's go there and take a look at it. Refresh this. Very good. What was my job ID one more time? This was 526025. So if I look for server output 526025, that's here. I'm gonna open it. Let's take a look at it. Very good. Okay, this gives you the instructions that you need to then access RStudio. All right. So bear with me here, but we'll get through it. Okay, so I'm going to need to open up another PowerShell instance. Okay. All right, separate. Okay. I'm going to take this command that we get from that output file here. Let's copy it. And paste it in your new window. Okay. All right. Ask you for your password, of course, of course. And then it's going to appear to do nothing. Okay. No fear. Let's go back to our instructions and see what we need to do next. Open up a web browser and point it to localhost 8787. So let's do that. Open up a web browser. Localhost 8787, take a look. Okay. Asking you for a username and password. Where is that username and password? Right here. Grab this username, grab this password, and put it here. Sign in. Give it a minute. There's your RStudio. Okay. This is on the cluster, right? So you can see that the file directory that I have here is my home directory. So this is what's in my home directory. So if you want to navigate somewhere else, you're free to do that, right? I can, my working directory. So I can change to my scratch, go wherever. I can open up files. Like in this case, if I want to take that SimScript1 that I had, here it is. I can open it up. I can make any changes, save them. It's all going to be saved on the cluster in the usual way. Make sense? Create new scripts, do whatever the case is, right? Now, this job is only active for 1 hour because that's all that I specified it for. So does that mean I'm going to lose access to these files? No, right? As long as you save it, it's saved on the cluster, right? When that time hits, your RStudio session is what gets killed, right? You can always create another RStudio session, right? No problem, right? But your files, as long as you save them on the cluster, will still be there.
So you can create multiple cars? No, at the same time, you can create only one session.
You can have multiple ones, right? So I can kick off one of these scripts, but then I got to do it again for a different instance, right? So I use that job script, run it again. I'll get a different job ID, and then I'll get a different login and password, and then you can have multiple instances, right? You can run this just like you would, but all the computation is taking place on the cluster, not on your local. Yeah. Sound good? So this is the interactive job. Now, when you're done with it, because this is a shared resource, you don't want to just close it out and then be done with it, right? You want to make sure to kill the job to free up those resources for other people to use. So how can you do that? So this little power button here with the current R session, hit that, it'll end the session. We're going to close this out. Okay. Go over to that other new session that you opened up, and you can either hit Control-C, or you can just close that out. And then finally, Go back to your queue. That job is still running, right? So even when you close out of RStudio, that doesn't immediately kill the job. You need to go in and kill the job yourself. Okay, so once you're done for the day, you've done everything you want to do in RStudio, just do S cancel and F and 526.025. And now if I check the queue, it's gone, right? So this frees up those resources again to be used by anyone else in the machine.
So there is another comment from Isaac.
Yeah.
So he says like, not only do your files get saved, I believe Matthew and I worked it out to save the session details as well. In case your job times out, it should lose original progress.
Oh,
And the default behavior was to store it in your Scratch directory, but it could have changed.
okay, I see. I see. So, but it saves the session details.
Yes.
Great. Okay. Fantastic. All right. That's all that I have time to cover, and that's all I'm really interested in covering. So that gives you, so what have we done, right? We've gone from no idea how to use the cluster, how to transfer files onto it and off of it from using a client, right? Using a GUI. We talked about how to install and load packages that you need, how to create a job script and run it, whether it's like a fixed script, or how to do things interactively through RStudio. Right, so that covers a lot of ground so far. So what have we not covered that I'd like to do in future sessions would be things like job arrays, parallelization, get some examples of working scripts that would work well. I probably want to work in conjunction with Isaac because it seems like he has a pretty good idea of how to do that with in the right way. And anything else? Is there anything else that's on y'all's mind about like things that we need to cover or things that would be useful here? Python maybe. You can also do a Jupyter Notebook interactive session, right? Instructions for that are already on the documentation here. So if you go to the documentation for interactive jobs, you can fire up a Jupyter Notebook as well. Let me find it. Yeah, example using Jupyter Lab. So if you want to open up a Jupyter Lab instance and an interactive session, the same way that I did with RStudio, you can just follow this and you can do exactly that. But is there anything else that you guys want to know about?
So is there any file management system?
File management system.
Like, I mean, for not Windows, for say Mac.
Yeah, so that's FileZilla. So that's going to be there's WinSCP can be used by Windows, but there's FileZilla that's available for Macs you can use.
Isn't it?
Yeah, FileZilla. It's FileZilla. That's one. There are many of them, but this is one free solution that exists. It has an interface that's similar to WinSCP, and it works on that. So you can use that in order to manage the files on Macs. Any others? Fantastic. All right. Well, I'll stick around for 5 minutes. And if you have any other questions or think of anything else, for those of you that are online, feel free to email myself, email Matthew. If there's an issue with the cluster that you need help with, email ArtSci help, and that will create a ticket so that we can get you the help you need. Either way, we're here to support you. We want you to make the most of this because it helps us justify further investment in the future that's going to be needed to keep the cluster up to date. The previous cluster was super old and it didn't have any updates for a long time. So it became very outdated and it lacked the investment needed in order to maintain it at the rate that we needed to. We want to do things differently with this one, but we need to make the use case clear to say all of our students are using it. Here's a long list of publications that have all cited the use of the cluster. So we need this resource. Otherwise, we're going to have to revert to the HPRC and kick all the jobs that way, right? So we don't want that to happen. We want to make this easy to use. So help us by making sure that you acknowledge the computing resources and also let us know once you published a paper that relies on that. Okay. All right. I think I'm done. Thank you all. Yeah. I don't know how to end this though. I'll just quit it.
Yeah, we can do that. We can do that.